Hello, world. Welcome back. We continue to talk about Newton's second law of motion in today's video. So it says a truck with mass 5.5 ton is accelerating up a hill whilst experiencing a net force of 20,800 Newton. The hill makes an angle of 15 degrees with the horizontal, and the coefficient of kinetic friction is equals to that much. And just to highlight important information, we're given the mass of the truck, but the mass of the truck is given in ton. Remember that in physics, our SI units for mass are kilograms. We are also given net force, and we are given the coefficient. So let us just write everything down. So the mass is given as 5.5 ton. It means we need to convert. How do we convert? You can just say 1 ton, that's what is given, is equals to 1000 kilograms. Okay, so on the left hand side, I've written information about tons. And on the right hand side, that is information about kilograms. Now, if I want to convert, when I write the second equation, it means on the left, I'm going to have information about the tons. On the right, I'm going to have information about kilograms. Okay, so we are given 5.5 tons. Where does it go? It goes on the left hand side. So I have 5.5 tons equals to, I'm going to call it x. So we want to know how much 5.5 tons is equivalent to in kilograms. So far we don't know that information. So I'm saying that 5.5 tons is equals to x kilograms, and we're going to figure out how much x is. So from there you can cross multiply. So you have 1x multiplied by 1 ton. So I'm going to have 1 ton times x equals to cross multiply again 5.5 ton. So I'm going to multiply the numbers together. 5.5 multiplied by 1000, I have 5500. So I have let me use black. I have 5500 tons multiplied by kilograms. So we want to know what the value of x is. So I'm going to divide both sides by the 1 ton. Divided by 1 ton, what I do on the left, I do on the right 1 ton. So the 1 ton and the 1 ton will cancel out. This ton and this ton will cancel out. I'm going to have x being equals to 5500 kilograms. What it means is, oh, it was actually given on the diagram. Okay, but it was just nice to prove it. I wasn't aware it was given on the diagram. So that is the mass. That's how we get 5,500 kilogram. It's not always that they're going to give you mass in tons and then convert for you within the same diagram. You have to be able to do this for yourself. Okay, there you have it. So that is the mass in kilograms. And then we were also given net force. This is F net. So F net is equals to 20,800 Newton. We are also given mu K. We were being told that mu K is 0.2. So we can clearly calculate the kinetic frictional force. And then the first question says, state Newton's second law of motion in words. That I have already done in the 3 previous videos. 5.2 says, draw a level free body diagram showing all the forces acting on the truck as it moves up the hill. Remember your axes. Parallel to the surface, x-axis. Perpendicular to the surface, you have y-axis. Where they meet, you can put the object. Always vertically down, you have the... Wait, now I'm starting to sound like I'm singing. Okay, so pointing perpendicular to the surface away from it, that is the normal. And we are also having kinetic friction. We're being told that this moves uphill. So it means kinetic friction will be opposite to the direction of motion. So this will be kinetic frictional force. So looking at that question, it says draw a labeled free body diagram showing all the forces acting on the truck as it moves up the hill. There's nothing about the scaling, and the question is 4 marks. So it means when you draw, we expect to have 4 forces. So this is force number 1, force number 2, force number 3. Where's the the fourth force? Question is, what is causing this truck to move up the slope? So if you have experience of driving, you probably know that to get a car to move up a hill, you need to step on the accelerator. So there is a force which is being applied by the engine, which is causing the car to move up the slope. So this is the force applied there that is causing the uphill motion. That is force applied. Force applied by what? This force is applied by the engine. And there we go. We have our 4 forces. And I can draw a duplicate over here where I'm going to be showing the components. So you have the normal. You have force applied. You have kinetic friction, FK. I'm going to draw the components in colors. Perpendicular, parallel component always pointing down the slope. And then you have the perpendicular component always opposite to the normal. If you look at this diagram, please do me a favor. When we count the forces on this diagram, we count 1, 2, 3. These red ones, these 2 in red, they represent a single force, which is the weight. So these components, both of them combined, we count them as one thing. So make sure you draw all of them, because if you draw one, then you don't get a mark for the weight. Okay, so that's our free body diagram. Then the other one says, calculate the acceleration of the truck. Nothing was mentioned about the velocities, displacement, so on and so forth. So it means over here, if you want to arrive to the answer, you need to use Newton's second law of motion. F net is equals to ma. What is the direction of the net force? It is uphill. What will be the direction of the acceleration? It will also be uphill. So your F net was given there. It is 20,800 equals to the mass was given 5,500 multiplied by acceleration. Then we can make acceleration the subject of the formula. Therefore, the acceleration will be, I'm going to grab my calculator, divided by, okay, when my calculator says the answer will be 3,78. I'm just going to keep as many decimal places as possible. Meters per square second. This means that the acceleration will be that much uphill. I'm just going to say uphill because they used uphill. And then the second question says, calculate the magnitude of the frictional force. Let us see. Which equation can we use to calculate kinetic frictional force? Because we have mu k, we can use Fk is equals to mu k multiplied by the normal. Do we have the normal? No, we don't, but we can calculate it. I want you to prove this for yourself, but the normal is equals to the perpendicular component of the weight. Then I can sub in. I have my Fk equals to 0,2 multiplied by perpendicular component. We said to calculate that, that is mg cosine of theta, the angle of inclination of the slope. So Fk will be 0,2, the mass 5,500 multiplied by 9,8 multiplied by cosine of 15. Let us see. Okay, I got myself a calculator, so I no longer use the one on the screen. 0.2 multiplied by 5,500 multiplied by 9.8 multiplied by cosine of 15. So I find that the kinetic frictional force will be 10,412,68041 Newton. There we go. Okay. And then the other one, remember, by the way, just to point this out, they said they wanted the magnitude of the frictional force, meaning that the size only. So hence I did not even write down the direction on that answer. And then the other one says, calculate the magnitude of the applied force. Let us look at the diagram. If you go back to the free body diagram, along which direction do we find the applied force? We find it along the x direction. So it means we need to sum forces along the x direction here. So sum of forces along the x direction is equals to the mass multiplied by acceleration. I'm using this equation because this truck is accelerating along the x axis. Which forces do I have along the x axis? I have the applied force. I'm taking direction of motion as positive, meaning uphill as positive. I have force applied from the free body diagram plus minus the parallel component because it's pointing down slope, plus I have minus Fk also pointing down the slope. This is equals to 5,500 multiplied by the acceleration. Okay. So I don't know how much force applied is, so I'm just going to rewrite this as Fa minus parallel component, just taking this one step at a time. Okay, so force applied is what we are looking for. Minus parallel component, we said we can calculate that by mg sine of theta. So straight up, I'm just going to substitute right there. So I have mass 5,500 multiplied by 9.8 sine of 15 minus Fk. Where's Fk? We calculated it. 10,412,68. I'm not going to be able to write all those figures. Okay, so I can simplify here. I have force applied. 5,500 multiplied by 9.8 multiplied by sine of 15 minus 10,412,68041. So over here I get something like 24,363,02 694. So this is equals to the mass multiplied by acceleration. We already have the acceleration from somewhere up there. So when you multiply these two things together, I'm just going to do this. 5,500 multiplied by 3,71818. Okay, so now you can transpose and make force applied the subject of the formula. You're going to have something like 5,500 multiplied by 3,7181818 recurring. So something like this. Force applied will be, let me try again, 5,500 multiplied by 3,781,81818 this part, if I multiply together, I get something approximately 20,800, and then I'm going to transpose this to the other side. That will become positive 24,363,02,674. Okay, I wanted to complete the calculation in a single step, but okay. Okay, so this plus 24,363, 02,674. Okay, so something like 45,163,03 newtons. That will be our applied force. And to get the applied force, I have decided to use Newton's second law of motion. But you were not forced to use Newton's second law of motion. If you like, you could have just simply used the definition of the net force. So I'm going to say or. Using definition, we have that F net is equals to applied force plus minus parallel component plus minus Fk, the minus of 4 directions. This, we already have it from the statement. 20,800 is equals to, this is what we are looking for, minus parallel component minus kinetic frictional force, which we had from the previous question, 412,68. And by using this equation, you could have easily found your applied force. Whichever method you go for, we should still get to the same answer. Okay. And then the other one says, how will the value of kinetic frictional force be influenced if the angle of the incline is changed to 25 degrees? We're talking about kinetic friction. If you want to know how it will be affected, you go back to the equation for calculating the kinetic frictional force. So Fk is equals to mu k multiplied by the normal. Question is, if they increase the angle of inclination, does mu k change? The answer is no, because mu k only depends on the type of material. So this will remain constant. Does the normal change? That is something that we can actually check. So I'm going to check if the normal does indeed change. So remember, we said for this question to calculate the normal is W cosine of theta. I'm going to say before the angle was changed. Before was with a theta of 15 degrees Celsius. The normal was initially 5,500 multiplied by 9,8 cosine of 15. Let us see. If I punch that on my calculator, 5,500 multiplied by 9,8 cosine of 15. Initially, it was 52,063,40 Newton. Let us see what the new normal is. When now the theta has been increased to 25 degrees. Normal will be 5,500 multiplied by 9,8 cosine of 25. Okay, if I sub that in on my calculator, it tells me that the new normal will be equals to 48,849.99 newtons. Okay, so clearly over here, the normal is affected. But from the equation, I want us to check the relationship between the normal and the kinetic friction. There's kinetic frictional force, there's the normal. So we're getting a straight horizontal line. What does it mean? It means for constant mu k, and indeed the mu k is constant. If the normal increases, fk will increase. The opposite is true. If the normal decreases, fk will decrease. So if we look at the result from an angle of 15 to an angle of 25, the normal was this, now it's that. It means the normal has decreased. What will happen to fk? It means that fk will decrease as well. So you can do this aside for yourself, because when we give these reasons, we don't want calculations. So your 5.4 is that fk will increase. We were asked to choose there. And then if you look at 5.5, 5.5 says give a reason for your answer. When we give reasons in physical sciences, especially in the physics component, we use equations to give our reasons. Which equation are we going to use here? We are going to use the equation that we used to get the answer in 5.4, which was fk is equals to mu k multiplied by normal. So the first thing is, we are saying as theta increases on our rough section, we have seen that normal will decrease. Point number one with a mark. And then now we bring in our equation. According to fk equals to mu k multiplied by the normal for constant mu k, or for same mu k as, hi, I wrote the wrong thing here. Oh, but my apologies. That was supposed to be decrease. Okay. According to that equation, for the same mu k, as normal decreases, fk also decreases. Okay, so when you write your reasons, okay, much better. When you write your reasons, you can't just start by saying that according to the equation, for the same UK as the normal decreases, fk also decreases. You must first give us a reason how you got to the statement that the normal will indeed be decreasing. So there must not be any holes in your statement. When you write your reasons, the reasoning must be orderly. I forgot the English term for it, but they must follow the order. First, what we know is they are increasing the angle theta, the angle of inclination of the slope. How does it affect the other things? Does it affect mu k? No, but what does it affect? It affects the normal. What happens to the normal when it increases? As theta increases, the normal decreases. So now we know for a fact what is happening to the normal. We can see where this relationship comes from. Why you are choosing to say as the normal decreases, because from the statement you have it that when the angle increases, normal will also will decrease. So then you get to the equation. According to some examiners, make the final statement 2 marks. Some say for mentioning that the mu k remains constant, you get a mark. But according to this examination, you get a mark for this whole statement. Okay, so just make sure that your points follow properly in order. That's it from me for today. I wish to have a problem where we analyze a graph. So I promise in the next video, we are going to look at graphical interpretations. That's it from me for today. Thank you. Bye.